Many people think the universe began as a single tiny point. They call this a singularity. It is a point of zero size. It holds all matter and energy. The story is common in books, movies. It sounds simple and dramatic. It has become the standard tale of creation. But the truth is not so simple. This picture of a definite starting point, an absolute beginning from nothing, might not be true at all. It is a myth that modern physics is now starting to question and break apart. The idea of a singularity comes from Albert Einstein's theory of general relativity. If you run the clock of the expanding universe backward, the math points to this single, infinitely dense point. All known laws of physics break down there. It is a place where our understanding stops. But this breakdown is a clue. It tells us that our theory is incomplete. It signals that we need something more, something new to describe that extreme first moment of existence. So, the notion that everything burst forth from an infinitely small point is likely just an artifact, a consequence of using a theory outside its proper domain. GR explains planets, stars, galaxies with stunning accuracy. But at subatomic scales, we need different rules. Let's explore this new idea. It is called the Big Bounce. Picture a cosmic U-turn. The Big Bounce model suggests the universe can shrink and then grow again. Imagine a universe before ours. It was contracting. Over eons, everything pulled closer together. Temperatures and density climbed to unimaginable levels. But instead of a singularity, something stopped the collapse. At maximum compression, the universe bounced. The event we call the Big Bang. Not creation from nothing, but an explosive rebirth. This reframes our cosmic origins into a cycle of contraction and expansion. Like a ball that compresses at impact, then springs back. The laws we use to describe the universe are split into two sets. General relativity rules the large and smooth. Quantum mechanics rules the tiny and uncertain. Together, they clash, especially in the very early universe. GR predicts a singularity. Quantum theory resists it. We need a bridge, quantum gravity. It's not one theory, but many paths seeking the same goal. Explain immense gravity at the tiniest scales, black holes, and the birth of the universe. Key idea: space and time may be made of tiny, indivisible bits. If space is granular, it can't be squeezed to zero. There is a smallest distance. That graininess can generate a repulsive pressure, powerful enough to reverse a collapse. How can quantum gravity stop a collapse to a point? Imagine the universe as a giant spring. The more you squeeze, the more it pushes back. Some quantum gravity models give space-time this spring-like response. One path is loop quantum gravity. Space is a fabric of tiny, discrete loops. They have a minimum size and resist being crushed. That resistance produces a repulsive force, the trigger for a bounce. Another route, string theory, replaces points with vibrating strings. In brain worlds, brain collisions can seed a hot new Big Bang. Different mechanisms, same outcome. No singularity, a physical process instead. A collapsing past saved by quantum gravity, reborn as our expanding cosmos. Science needs testable ideas. The Big Bounce must make predictions we can seek. If true, it should leave traces we can find. One hunting ground, the cosmic microwave background. The CMB is the afterglow of the Big Bang. A prior contraction might imprint unusual large-scale patterns, even cold spots. Gravitational waves could carry a different history from a bounce. The bounce itself would reshape those primordial ripples. Future detectors may be sensitive enough to hear that signature. The signals are faint, but our tools keep improving. Better instruments give clearer views of the early universe. The right pattern would be revolutionary, a glimpse before the Big Bang. The idea of a cosmic bounce reshapes our origins. The myth of a singular beginning gives way to a more elegant picture. The Big Bang may have been a pivotal transition, not the first moment. Our cosmos could be the successor to a collapsing predecessor. It's a profound shift in perspective. Quantum gravity provides the key. By weaving the large with the small, it removes the paradox. The laws of nature may prevent an infinite point, turning ends into beginnings. Whether loops or strings, quantum physics makes a life-giving bounce possible. It's unproven, awaiting decisive evidence. We must search for echoes from a pre-bang era. Our story may be grander than we imagined, perhaps part of an endless cycle.